Okay, ladies and gentlemen, thank you for joining us here today for this second session in the openBIM Awards program for 2023. In the next hour and a half, we've got two categories that we're going to work our way through, 5 finalists that we will be hearing from. And to introduce the session and the first presenters, I'm going to hand over to Claire now.
Hi and welcome. As Dan said, my name's Claire and I'll be one of your moderators today. In this session, finalists from the Asset Management and Technology Solutions categories will present their entries. This session is scheduled to last 90 minutes, including time for questions at the end of each category from the jurors. The session is being recorded and will be made available as soon as possible after the event. Before I hand over to the speakers, I'd like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted. If you wish to make a comment, please use the chat box in the control panel. For the attendees here in the room, please keep background noise to a minimum. I'd also like to bring to your attention our antitrust code of conduct, which is on the screen now. So without further ado, I'll invite the first finalist on stage now, and in the asset management category, they're from Hong Kong Water Supply Department.
Thank you. Good morning, ladies and gentlemen. My name is W.Y. Wang, and I'm here with my teammate C.C. Leung to represent the Water Supplies Department of Hong Kong. Today, we are excited to introduce our project and show on the screen. Over a decade ago, our department acknowledged the importance of digital transformation and efficient asset management. We are currently in the progress of developing an asset management information system, which is designed to integrate openBIM, openGIS, AI, and IoT technologies seamlessly. The objective of this system is to consistently enhance the customer experience, reduce operational costs, and maintain our competitive edge over time. Our presentation will be divided into 5 parts. And let us watch a short video giving the key information of our project.
Hong Kong experienced water shortage in the 1960s. With the help of the Guangdong provincial government, water from the Dongjong River has been transported to Hong Kong since 1965. At present, it supplies about 70% to 80% of Hong Kong's water consumption, becoming Hong Kong's main water source. The Water Supplies Department, WSD, has initiated the first stage of an ambitious program aimed at transforming the control and maintenance of the Dongjong Water Trunk Transfer Network system. We adopt some openBIM technologies in the project, such as BSDD, IDS, IFC, and COBE, and integrated them with WSD's operational requirement for our asset management information system. IDS defines the information required at different stage of the asset lifecycle. Aid by BIM Checker. This improves communication and collaboration, ensuring accuracy and completeness of information. Additionally, we integrate the BSDD with WSD's standard to standardize asset data to ensure accurate sharing with our AMIS. We have introduced several new programs, including the Smart Trunk Transfer Support System, STTSS, establishing new Asset Management Information System, AMIS, and AI leakage detection by leveraging openBIM, openGIS, AI, and IoT technologies. openBIM facilitates the integration of data from various sources, enabling WSD to proactively identify potential issues in the system, optimize their asset management practices, and enhance the reliability and lifespan of their assets. This results in several benefits such as improved efficiency, reduced costs, and enhanced safety. The BIM lightweight engine enables BIM models to be displayed in different formats on a browser, including exploded views and walkthroughs. Users can conveniently view spatial information and asset attributes. AMIS has several main functions to manage assets effectively, including basic information, transaction record, maintenance records, inspection records, monitoring data, special record, and failure record. These functions help ensure that asset information is complete and accurate and that assets are maintained and monitored effectively. BIM-AM in AMIS enables visualize the assets and show status alerts, thus inspectors can quickly look for that asset for inspection. Inspectors can also make good use of AMIS to do simulations and make action plans for emergency. Asset data can be easily reported through eForm and stored in AMIS. Our Smart Trunk Transfer Support System, STTSS, uses GIS, SCADA, hydraulic modeling, and artificial intelligence to optimize pump and valve operations. The STTSS comprises 3 models that work together to calculate the optimal scheduling scheme: hydraulic modeling, forecasting modeling, and operation planning and scheduling optimization modeling. It helps optimize the allocation of water resources, formulate water delivery scheduling schemes, reduce operating energy consumption, improve the operating efficiency of the entire system, and effectively optimize linear pipelines management. AI can recognize the frequency pattern of noise and differentiate between background noise such as birds or traffic and the noise caused by a water leak. It will allow us to use the potential outcomes and benefits of such a deployment as the frontline protection and monitoring of these critical assets. The project achieves several goals in the aspects of reliability, cost saving, workflow optimization, and asset management improvement. We have saved 14 million and aim for 9% cost saving in the continuous development. We are delighted to participate in the BIM Awards and receive recognition. We will continuously improve our works and contribute to the industry.
Well, I hope you enjoyed the video, and let me tell you a little bit more about our projects. Okay, this is the typical diagram of a water supply system. Basically, simple words, from source to tap. And 20 years ago, we already implemented ISO 9000, and well, we adopted the total management approach and adhering the international standards like ISO 9001, 50001, and 55001 to enhance our services. So the keywords of the asset management is to satisfy the customer needs. At the same time, we want to be the world-class asset management. And before we have our old works order system. As some of you may be aware, then the system doesn't support the drawings or neither support the O&M manuals. So actually, our staff spend about 30% of their time looking for the right information. So for the new system, the AMIS systems, so we streamline our business workflow. Okay, so we can enable the right to deliver right information to the right people at the right time. Okay, before our asset management concepts was cradle to grave, but today we want to show you how it can be done better. We call it lust to dust, from inception to disposal, okay? And in 2022, we managed to secure the funding for 18 million for development of our AMIS. Actually, the project was launched early this year in 2023. And for the scalability of the projects, as you can see, it will actually have the full spectrum to cover all our critical assets, including pumping station, water treatment work, water mains, reservoirs, etc. So basically, it can provide all the, take care of all the assets for asset management, no matter it is a surface asset or the underground asset, For the underground asset, actually, we have 8,000 kilometers. For the DJ water mains, we have 100 kilometers. So this new system will take care of it nicely. So for the BIM AM workflow, it's quite simple. First of all, we develop a BIM model, and then a contractor will fit in the asset data into the BIM model, and then we use the COBE to exchange for the information exchange. So the asset data can be transferred to the AMIS, and then we can create the asset register, and then we hand it over to our maintenance department to carry out their maintenance work cycle. Simple, right? Actually, for the underground asset like the water mains, it's more or less the same. We lay the pipes, we do the size measurements, and then we do the point count, and then we build the 3D models, the BIM models, and then we store it in the DMS system, the digital mapping system. The digital mapping system, actually, we developed an API to directly interface with the AMIS system for asset management. So some of you may ask me, okay, is it 2D or 3D? Actually, it's both. 2D and 3D should coexist because it can suit the different business needs, because some 2D application may be better, some 3D may be better. So we want to have the best of the both worlds. And for the summary of openBIM use, our adoption of openBIM, openGIS, including IDS, IFC, BSDD, COBE, JSON, XML, CTGML, interoperability is the core of our strategy. So now I'm going to explain a little bit more about the new asset management systems. Actually, it is designed to help our staff to handle all the assets from when it's born, at least, to all the way to its end. Okay, all the information are stored, how long what it has been done, and so on. So and the GIS and the BIM are actually openBIM, and they all support openBIM, openGIS system. We use the API to interface with the AMIS systems. So actually, 10 years ago, WSD, our departments, already started the development of the COBE. We understand and we realize this is very important to us. So we actually drill into the database level of not only the database in the AM system, but also the BIM. So we want to make sure that actually the database are fully integrated. So we want to get it done right at the first time. So this is the showcase for you. This is actually one of the largest pumping stations in Hong Kong. This is a 24 megawatt pumping station responsible for pumping the water to the water treatment works. Another one showcase is the water treatment work. Actually, it is the BIM IoT, because like the IoT can have a real-time link to the AM system, and on top of that, it can provide the real-time water monitoring for our operator as well as the chemists, the in situ chemists. So another project that I like to talk about is the smart transfer support system. I don't know if you know, because like usually for water industry, energy is a big operating cost for us. For WSD, we spend about 1 billion Hong Kong dollars for the electricity every year. Okay, so we want to optimize our operation by using these STDS systems. So this system, the sound actually you heard is actually from the birds, from the dog butt, because like actually the sensors are connected to University of Adelaide in Australia. So the professor will help me to analyze what happened to our asset, to our water mains. Say, for example, if anything go wrong, it will give me an alert, okay? So we are committed in excelling openBIM and openGIS. Recently, we find a software vendor which can support the platform, providing both BIM and GIS. This is very important. For AMIS system, usually it's only which can handle the surface asset, not the underground. We want to build a new system can actually handle both, okay, in real time. Last year, one of the first initiative was completed because we completed the replacement R&R projects, replacement and rehabilitation projects. We actually managed to save 40 million of the electricity just by replacing the old pipes alone. There's more. Okay, there it is. So the annual saving that was 40 million. Okay, and then the carbon footprint, and of course we are not stopped yet. Last week, before I come to Oslo, I issued another tender to improve the AMIS further, to use more openBIM and openGIS to make sure then actually all the information from BIM to AM is okay. That's the end of my presentation. Thank you.
Thank you. The second finalist in the asset management category is HOCHTIEF ViCon and HOCHTIEF PPP. And René's coming to the stage now.
Thank you very much. Good morning also from my side. And first of all, thank you, buildingSMART, to give us the chance to present our project today to you. Our project is a digital twin for an infrastructure project in Germany, especially for operation of a motorway. Our companies, two parties that came together, my company, HOCHTIEF ViCon, which is a specialist in building information modeling and information management. And the second part is HOCHTIEF PPP, which stands for Public-Private Partnership Projects. And this is an organization responsible for design, construction, and operation of infrastructure assets around the globe. And our joint goal was here to create an asset data management and operation that is data-driven. So we wanted to create a data set that is directly usable for long-term operation of our highway project. Our highway project is the A6 motor highway in Germany. So we had a part of the highway which is 50 kilometers, and it includes 70 bridges, 12 resting facilities, 45 rainwater retention basins. So it is quite a big project, and we started already in 2017. So it's nothing we started last year or so. So we are 6 years on the road, and it is a project combined design, construction, and operation. And it runs in the field of operation for the next 30 years. So it is crucial really to create right from the beginning a databases that can support to be efficient in the management and operation of the facility. Yeah, our objectives, our goals, our challenges we had so far. First of all, we said we want to be the organization that has the first digital twin in Germany in place for infrastructure objects. And that was also supporting the plan, the governmental plan in Germany, that they want to make sure that from 25 onwards, the infrastructure, especially in the highway sector, and the operation of the infrastructure is going to be supported by digital twins in future, without having, of course, a clear plan what exactly need to be included into such a digital twin And our goal was at 6 years back to really support this and create a good example how to manage highways projects very efficiently. The challenges we had, you can see here on the screen, is of course dealing with a big amount of data and data that came from different systems, data that is differently structured. We also had assets with different information maturity. That means maybe we had tunnels, bridges, parts of the road, and those were differently documented in the past, and we had to work with this documentation which we received from the past. We had existing assets included into this 50 kilometers, which are older than 50 years already. And we had, of course, a wide range of different data sources and authoring systems that need to be considered for our digital twin. We built up a concept, and we called it the digital twin fish. And the concept included already right from the beginning during the design stage to collect data that is going to be used for asset management, and also to use the data for performance controlling and performance information. And that runs through the design, construction, and operational phase. And you see that the performance information during the operational phase is, of course, much more crucial than in the design phase, for example. And demolition, of course, comes at the end. So that was our concept, really developing right from the beginning for all newly developed assets in this highway project, but also for the existing ones, develop a digital twin. How we did it? We said, of course, we have geometrical data, 2D, 3D information. We have documents that came from the past 50 years. We have other data, which I will show a little later. And we created in the middle a database. And this database here is, let's say, the core of the digital twin, because we said we take data out from different authoring systems, like the design systems, where we have Civil 3D, for example, Revit, Primavera, and other systems. And we use standardized formats to collect data coming from these authoring systems and to transfer it to our digital twin, and to transfer it either into a digital 3D model or into our database or document storage. And the way we did it is for geometrical data, we used the IFC format, we used the MVD format, and for other data, we used the methodology of IDMs, information delivery manuals. That means we specified what are the data we need from which authoring system, and how is that going to be transferred into our digital twin, and what we want to do with it. So we thought about the data input, the data output, and maybe how this data is going to be integrated into other information that came from other sites. Because when I said we have 50 years old assets included into this road, there is a national database coming from the authority, which is called ZIP Buildings. This is something we have to consider when it comes to the status of an asset. So how good is this asset going to be managed so far? And this is also included into our database, because we, first of all, need to take information out of this national authority system, but also on a regular basis to push information back. So we not just said this one way of information, we said, okay, we go both ways. We take information out of it, we work with the information, and the output in our processes goes back into the national database. There's another national database, the environmental database. There is accident data. There is weather information coming from sensors, and other sensor information, operational data, and so on. We specified use cases for our digital twin, of course. When we put all these data together, important for us are use cases during design stage. I think that is very familiar with you. And the new thing was really the use cases during the operation, that we thought really, what can we do with this information, and how can we embed information in standard processes during the operational phase? And we also saw it here how this information can be exchanged. And we also developed here IDMs for each of the use cases. Very crucial, that looks a little bit, I can explain, maybe there's a bug in the size of the font. We have had the situation that we need to deal with different structures of data. First of all is the schedule view, which is this one, and that is called so far the work breakdown structure. Then we have the cost view, which is mainly within our cost estimation software, but also the ERP system, that is the cost breakdown structure. Then we have the systems breakdown structure, that is more the view from the asset management side. And we have the locational view, which is mainly the structure how the national authority systems are working. And our goal was to find a combination of these different structures. And we called it the project data structure, the PDS. This is a structure combining all these different needs during the project. And that was a very crucial thing to manage, how these different data structures come together to become, or let's say to come into the position to automatically, based on rules, link information from different sources together. That was based on the project data structure. Here you can see some of our use cases we are supporting during the operational phase. There should now come a movie. I don't know if that starts automatically. Okay, then maybe I explain a bit. So what are the different use cases we are supporting? There's, of course, conditions recording that are national standards we need to consider. So there are regulations how an asset in infrastructure need to be controlled over time. So when it comes to a bridge or a tunnel, there are controlling mechanisms, and we support it with our digital twin, this standard mechanism. We have analysis of data sets of any other tools which are involved in the national setup. We supported the collaboration with the firefighters, but also with the police department or any kind of emergency. We have daily control or patrol. We have warranty and maintenance information. We have analysis of data from road inspections, which are also regularly organized. This shows, let's say, one of the final end results. It is a dashboard, and that is one of our digital twin system. And here you can see the different use cases so far. And I explained a little bit on top here our data structures. And you see that is the building type. That is more the structure of the work breakdown. Under here you see the locational view. And by clicking on those elements, you can filter the information according to the structure. And then you get information in each of those use cases. You can see, for example, the defects management, the zip buildings here, the structure. That means in which conditions are the different structures. Accident management, that is maybe a good example. What I learned, because I'm a construction engineer, and in these 50 kilometers, we have one accident per day as an average. You can say the Germans are stupid drivers, but this is how it is. What means having an accident? An accident is a project for us in the field of operation, because the accident can have an impact on the asset. Maybe the asset can be damaged from the accident. That means for us in terms of operation, we have to organize with the police department what happened, who is responsible for the accident, because that is the person that needs to pay for the damage. And we need to repair, of course. And also then we need to deal with the insurance companies to get our money back for operation. And there you can see that are all own little projects. And this happens once a day for the next 30 years. And we can also see here where in which area are the accidents. Yeah? And if I go to here, construction and design progress, we see overall design progress 70%. And here, of course, we get more detailed information, and then you can click into each use case to further understand your project. What are the major benefits? Of course, save time, make better decisions, have a better collaboration between all the different stakeholders, and improve quality in everything you do, more safety, and of course, it is the basis for many decisions you need to do. And many decisions where you not often have much time to analyze the data. What's not shown here on the slide, this project 2 months ago became the first certified project in infrastructure in Germany according to national sustainability standards. So this is really the first one. And the digital twin served the basis to get the right information for this certification process. And it was firstly done by the DGNB in Germany. And yeah, we are very proud that we made finally the gold certificate. And we can say that during operation already, we saved approximately 10% of our money for operation. And by using several sensors, I can give you an example with, let's say, the waste management. We have in the bins where the car parks are, sensors installed that we get an understanding which bin is fully loaded or which is empty. And then we can plan already from our office where to go to empty the bin and to be mostly effective. My time is over. I thank you very much for your attention and looking forward to your questions now. Shall I stay?
Yeah.
Yeah, thank you. Please do stay there. And if the first presenter could please also join me on the stage. And we will open the floor to the jury for questions. We have a colleague joining here for the Q&A. So, Lex, David, Yusheng, whoever's ready, please feel free to ask the first question to one of these projects. Thank you.
Yeah, I have one question for the first speakers. You have mentioned that you are using the API as converting what you are covering into your system. And we would like to know which are the benefits of using the advantage of using the open data structures such as the IFC schema ones for that conversion. Because you can take data from many other sources, so we would like to know which are the advantages that you see using that type of data structures.
Right. Thank you very much for your questions. Actually, the API was actually invented because of the COVID challenges. I know, I don't know, during my time, it was very, very difficult to export the BIM. I mean, it's easy to export, okay? You use the software to export the data into a file, but it's not structured. The point is not structured, okay? The worst still for asset management, you have parent and child relationship. It's even worse. Actually, I can share a little bit of experience with you when I went to Shanghai with one of the respectable company, BIM company, and then I asked him, why don't you actually add the asset hierarchy into the BIM software? Well, what they told me is, well, you have a really excellent idea, but no, sorry, we have too much work to do, okay? So that's why our department actually hire good BIM consultant to help us to develop 2 API at a time. The first one is for the COVID challenge is to we have already built the BIM model. So actually, we want to have a special you may say a plugin to export the structured data to the AMIS system. In two meanings. At the time, we have the old system, okay? So the API must be compatible with the old systems, the AMIS. That's not it. It must be actually compatible with the new system as well. So the API serves two purposes for the export, okay? And another question is that we also develop an API, not for export, for import, okay? Because a lot of industrial vendors didn't have maybe money, time to invest a Revit model, okay? The Revit, I mentioned the name, okay? So the software, okay? So what happened was they can actually use the spreadsheet, okay? Everybody has a spreadsheet. And this COVID spreadsheet is brilliant. It's free of charge. It's well organized. Actually, when I studied a little bit about COVID, actually, I thought it was not a rocket science, but it is a rocket science. Actually, it was used by NASA because NASA has tons of vendors, okay? So each vendor will use the COVID to fill in the asset data, okay? So actually, we spend a lot of time with our development bureau to use whether the OMI class or the uni class, okay? The British or the American. Okay, so at the end, somehow we choose the OMI class, but actually, what we did was we actually have a Kobe light version, because like the Kobe that we develop is specially unique to suit our water industry, to suit our department. That's why we developed the API. I hope I answer your questions. Thank you.
Hi, I got another question. You have mentioned of using BSDD in your process, in your asset management process. Can you just describe and give up some details, which dictionary are you using and how it's take effect in your asset management process? Thank you.
Right. If I could just say, please try and keep the answer a little bit shorter, just so we can give the others a chance.
Sure.
As well. Right?
Okay. Keep it in short. Is mainly for pumps. We have in our department, we have a lot of pumps, different types of pumps. Actually, because we have a long history of using pumps, 150 years, from diesel pump to electrical pumps. Okay, we believe the BIM template can actually complement with the BSCD, okay, the buildingSMART BSCD template, because like BSCD, I've studied the BSCD is quite generic, okay, but for our case, we can utilize our experience and expertise, the knowledge that we have gained throughout the life cycle to fill in the attributes, additional attributes for pumps, because like for the building pumps are very different from the one that we use for WSD, because we need the reliability. So the materials are different. Say, for example, for the saltwater pumps, we use the super duplex stainless steel, but normally you can't buy it from the markets. So we can use the BSCD as a backbone, and then further develop the attributes to make it more usable for us applications. Thank you.
Thank you. If we could please have a question or two for the other project now, please, Jury. Have any?
Sorry, Dan, what did you say?
Do you have a question for the other project?
Yes, of course. I was actually one, but no. I was thinking about the question for the level.
Yeah, given the time, it would be good to come this way.
Yeah, hi. You have mentioned the 4 schedule view as 4 different view of EDM integrated together as a project data structure. Can you give us more information how this 4 EDM or MVD, how it's for MVD, how it's work together and provide you kind of like, I don't know, check or information validation? This for schedule view, cost view, function view, and the location view.
Yeah, it's not only a view, it's a real matter of how to structure data in your project. And we have regulations when it comes to cost or when it comes to schedules. And also we have regulations when it comes to documentation of infrastructure assets in Germany. So there are structural or requirements regarding the information structure. And what we did with the IDM was really to understand what is the data input in each of our use cases for operation, what is the reason why we collect the data, so what we do with it, and what is the output of the process, considering also the structure of data, in which structure we get data, in which structure we need to push data out. And why we did it is really to find a mechanism that we automatically combine and connect data. So how to bring cost and schedule information automatically together that is based on a data structure. But if the information doesn't fit to each other, if you have two different structures, it doesn't work automatically. And that was our focus through all the different use cases within our digital twin, to find a structure that can feed all different processes and bring them together and automatically interlink them.
Thank you. Just for make sure, so these 4 different view, different MVD, finally it's work together. It work together, combine a kind of system behind. In different use case, we have different MVD involved in and take part of.
It depends really on the authoring system. For example, the Primavera P6 schedule works in a work breakdown structure, and we didn't change it. We said this is the structure for this particular authoring system. But when we take this information out of the schedule and import into our database, then we need to think what is the, let's say, leading structure at the end in order, let's say, to have one compository of all information for the project.
Less than a minute left, so one last quick question.
Okay, a very difficult question. No, just kidding. When creating an IFC file from an authoring software, most of the time it's a file, and then you will probably import it into your database, and then it turns into data, or does it stays a file which is being called while you need it, or how does that work in your system? Because you probably have a lot of files in your project.
Yeah, and also a lot of, let's say, we didn't have one authoring system for 3D models, for example. So there are many different, depending on, let's say, we have 50 bridges, depending on the different bridge, different system. But what we did is to specify a standard with the IFC. We never said that we require a particular system for our designers. We left it open and said, as long as you can deliver us an IFC model, and we also predefined a structure for models as well. We not just said IFC is the minimum requirement. We have IFC plus a structure for the model itself. And then we did both. We first stored the model itself as an IFC file to view, and the data view I have showed in one of my slides, that was just the data numerical side. We have also, let's say, a second view combined with the geometry that you can, let's say, understand your information also in types of geometry. But we also exported the information out of the IFC and transferred all information into our single database. So IFC was really the transferring format into our SQL database.
Was it also the foundation for all the other like scheduling or costs? Do you also use the same structure, the same in your cost analysis or in your schedule analysis? Do you use the foundation structure of IFC in that?
Yeah, that is what I wanted to explain, the cost. And when it comes to ERP system, cost estimation systems, they work differently. We have in Germany, we have national requirements how to structure cost information during design and construction. And we said, this is a regulation we don't touch. You work with your system in your cost breakdown structure according to national standards, but we define before you start, what is the minimum information we take out and link it to our project data structure. So we, before we started, we defined where and how the cost information comes into our database, and what are the opportunities, how to interlink them later on.
Thank you. We are at time there, so we'll call it a day for this Q&A session. Thanks for the questions. Thank you to both groups of presenters. And we will now vacate the stage so that Claire can get the next category underway.
So the next category is technology solution, and our first finalists are from Wings and Associates Consulting Engineers.
Good morning, ladies and gentlemen, judges, friends of International Friends Club. We are Wings and Associates. We are a group of AEC professionals. We consist of architect, engineer, and MEP engineers. We are running a large project in Hong Kong, satisfy the BIM requirements set by Hong Kong government and CIC. We need to input thousands of information inside the BIM model to satisfy the LOIN, which is the level of information needed, especially the LODI, which is the level of development information requirement. So although we live in a small city in Hong Kong, but we have a big passion. We try to satisfy the government requirement, but it's very hard. We spend a lot of time. We want to do more with less time. We think about whether we can develop some technology with one button, and then you can satisfy everything. So in short, we want to be more lazy, all right? Spend more time with our family. So we developed something which is, we call it openBIM Checker. Let's see what we can help for the industry. So it is an IDS-based solution. It's checking tools, and it's very easy to use. It's a localized solution at the moment. We specify for Hong Kong, but at the same time, we develop for the worldwide. And it facilitates collaboration. Not only ourselves to be lazy, but everyone can be lazy, all right? And then we expand potential for the expansion because we have open API as well. Very cost effective. We think about whether we have a lot of BIM software to create the model, and we have lots of documents, Excel, everything. What about we can make it into IFC and IDS as a requirement, and also some PDF to check against the information inside the model and also the 2D drawing. So we developed an open checker in both local solution, which is run in Windows, or running in the cloud on the web. So on the design stage, we have a function as a model inspector, which is very easy to check the model with a very layman terminology. We also can think about whether we can check the information from the 3D model against the information from the PDF. So we have the verification function. And we also, in order to satisfy the LOD requirement by the government, so we have this LOIN standard checker. So what we are doing is we have the IDS definition, a specification. We have the IFC model. We check against the LOI requirement, whether it satisfies the 300, 400, or 500. And then result can be exported to Excel report, which is very easy to understand for the government. And also we can export to BCF for collaboration. So we follow the roadmap of the buildingSMART. Actually, we can provide a IDS for the modeler. The modeler know the IDS requirement. They create IFC, and then they submit to the government. So the government will check using our checker to check against the IDS with the IFC model, whether they satisfy the LODI requirement enough. And then the result, as I say, will be export to BCF and also the Excel report to check against. You will see a very simple idea, but to make it simple, we put lots of effort inside the software to make it simple. So, and also coming soon, we will have the open CDE API. After the result, we'll synchronize to other CDE and also the BSDD definition. We populate the information definition BSDD into the model and export to IFC. So let's check it out, the first model inspector. So this is very easy to use model checker. For example, I want to see the BIM, I want to see the column. You don't need to know about what's meant by IFC column or what's meant by IFC BIM. Just click on, I want to see the BIM, I want to see the column. Then it can filter out the story, everything you need, cantilever beam, foundation, everything we will categorize. And then we have a data verification. We have an IFC model and we have PDF drawing. So whether we can, so let me check you. So whether we have a load an IFC file, and then at the same time, we load up a PDF drawing. So some data inside will be checked against each other. So whether the submission of the drawing, the data inside as a table will be collaboration, will be same as the IFC data. And then the result will be highlight for your easy follow-up. And because we want to make life easier, we have the ISC converter so that the clients no need to learn a lot on how to create their requirement based on EIR or their OIR whatsoever or PIR. So very easy that you create the Excel sheet and then we can upload the Excel sheet to our web. And then we'll change into the IDS XML file. On the left, it is the viewer. On the right is the human readable tree wheel, which is very easy to understand and check against. So once you have done, you can download the IDS file for use, okay? So it's very easy for the government to implement. And then the LOIN validation. So what we are doing is we have an IDS specification, we have an IFC, and then we have implement into which is the zero carbon part in Hong Kong. This is actually the buildings in Hong Kong. So first of all, load up the IFC model, which is same as you see. And then we load up the IDS files. So this check against the requirements set by the government, how much information inside is corresponding to 300, 400, or 500. And then once you click, you can see very easy to understand all the requirements, whether they are satisfied or some is not satisfied yet. So we calculate all 7 criteria set by the government, which is localized solution. We also can see the object property right in the browser. And you can see the check, we can check the missing parameter, missing value, or even the incorrect value inside. And then we export to Excel. You see all has been highlighted for the government to check. Very easy to use. So you just chase against those mistakes, and then it will satisfy eventually in the life cycle. Eventually, if no color, then it's satisfied. And also we'll export to BCF file for later use on collaborations. And here is the requirement set by Hong Kong for your reference. So we consist of 7 requirements inside the model. But not only the 7 requirements, but each of the requirement has quite a lot of different requirement parameter or the value put inside. For example, the project information, general properties, design classification, manufacturer conditions properties, or verification properties. For example, inside some of them, they will need your project name or project location whatsoever. Everything needs to be put inside the model. If you're missing one of them, you cannot satisfy what requirement. And then we can check against it, all right? So it's very easy to visualize the requirement, whether you meet the requirement using the gauge reader. So here are the mandatory and the required information set. We put it into IDS so the computer understands how to check. And we run the project as a key result. So we have run some real projects. So you see the number of property required need to be checked against the time required to check the model. So if more properties, you need more time. For the human checking, you will see there's not possible in some points of view. So that's why the government usually do the spot check. They can't check every information. So we suggest if you use the openBIM checker, without the IDS converter, you create the IDS yourself. It is manually, you can do it. And then you can do it with or without the IDS converter. So how is the result? You can see that we estimate we have some statistic around 100 of object. It will start to have the benefit because you need to spend some time at the beginning to create the IDS. All right. But after you create the IDS, you will find the benefit on the purple side. These are the benefit and the time saving. It's which about 80 to 90% time saving after this point. If you're using our IDS converter, then it's much more easier, more benefit even. If you have the model more than 30 objects, then you have gained the benefits. You still need to create the IDS converter. You do something, but less time because we have some converter to help you to life easier. So we have run over about 20 real project in Hong Kong using our openBIM tracker, which is including like the residential project or drainage or commercial project, government project, and which is follow actually the CIC BIM standard general, and also expand to the different standard over the world. And also we are following the buildingSMART technical roadmap, including the IDS, IFC, BCF, BSDD, and also create some UCM. So Wings, although we are not a software developer company, we are a group of people, professional with passion. So we want to create something for the future. So we proudly announced that we will decide to provide a free trial for everyone, especially for all government department and for the company in Hong Kong, to test it out, to try it, to use it, and we improve it. We commit into the development. We are not just play software. We commit to make sure the IFC HK, the roadmap can go on with our humble development. So we hope to have the win-win situation. And in the way forward, we will have a plugin for the BIM authorized software, for example, Tekla Structure or the Revit or the ArchiCAD, so that directly inside the model, it can populate the BSDD data to the model. And then once they have this parameter inside the model, they can export the IFC right directly for the openBIM tracker to check against it. So I hope this development could help the people to use more checking mechanism to save them more time in order to, to have more laziness to do more other things. All right. So, and here is, as I said, we are the engineer, we have architect, and myself also a BIMer, and we have programmer, and also we have Vincent is our director of the company, and Ken is our engineer and the BIMer. York is also our research and development manager. So what we think to success make it into the software, we should have a professional, we should have a BIMer, and also have the programmer work together for the future. Thank you very much. This is our presentation.
Thank you. So the next finalist in the technology solution category is ACCA software, Michelangelo.
Hi, everyone. I am Michelangelo Cianciulli from HKSAR Software, and today I would like to show you how it is possible from a world of construction to deliver and to construct a single digital twin. In this presentation, I will tell you the story of usBIM.geotwin, GIS digital twin, which is the latest technological development from HKSAR Software for the BIM to GIS integration. Now, if you are wondering why this should be taken into account for the buildingSMART awards, I will tell you the three main reasons that we believe that is really an innovation in the openBIM field. The first thing is that it has been built with the scalability in mind. That is, when we had a look on the market on the BIM to GIS integrations, what we have seen is that they promised a lot. They promised to have smart cities and digital twins with possibly unlimited scalability. But what then we see in practice is that this promise is often almost always not delivered. So what we have done is that we followed a different approach, which I will talk about to you later to explain some technical details in order to be able to view, analyze, and manage all construction data around the world in a single digital twin with the power under the hood of IFC openBIM and GIS. Going a little bit more into technical, and this is the second reason that I give you to consider this as an innovative solution, is the fact that we have connected two different platforms. The ArcGIS platform from Esri and the usBIM platform for ACCA, which contains the BIM data. But keep in mind that this is not the typical integration. This is a dynamic connection between the two platforms. This means that there is no exchange of static files or static data, which gets stale like the very same moment that you exchange it. Rather, it is done all via APIs, where the GIS side queries and interrogates the BIM platform, the openBIM platform with the IFC model, to get the data that it needs to do its queries, its spatial analysis, and so on. We will see some examples later. And of course, last but not least, everything is based on open formats, which means that we will see how IFC models up to the version 4.4 will be used to deliver some of the use cases that you are looking at here, such as the asset management, asset operations, facility management, IoT, and so on, both for the buildings and infrastructure domains. So I will show you a video in which we will see basically this technology in action. It will show different use cases, but keep in mind that these are just some, because with this technology, you can really think about your own new use cases. So we will start from our usBIM platform. So here is where the openBIM data is stored. This is a model, a federation of models, which contains all the objects. For example, here we are looking at MAP objects, and we can deploy these models on the map, on the GIS map. In particular, we can see that we have deployed the federation 4 times, and we placed it on the map. Most importantly, all the data that was available on the BIM platform is still available from the GIS view. In fact, if we select any object, we query the platform, the BIM platform, and get all the information of the IFC file. So you are already looking at how this scalability that I was talking about is done in practice, and we will see later how we will use the data, the actual data, the up-to-date data from the IFC models to do the queries from the GIS side. Here, we are showing that everything that was happening on the BIM side is possible to do on the GIS side. And of course, all the functionalities such as visibilities and so on, so what you would expect from a viewer, are still there. But we are on the GIS world. Moving on to another example, this is the city of Barcelona that has been completely modeled in IFC. There are more than 2,000 IFC files that have been put together on the map. And yes, the level of detail, it's not that great at the moment. But of course, when the government needs to and will have more detailed models, then it is always possible to substitute the existing models, the low-level detail models, with the new one, like the example that we are looking at. And keep in mind that this is not just an example of geometry, because what will change is also the data, and also the special queries that from the GIS side can be done will have different results based on the data that you have at the moment from the BIM world. So here we are looking at another example in which one building has been substituted in the city of Barcelona with a more detailed one, because it was then made available. This is another interesting example because it is a city of historical interest in Morocco and shows that sometimes we also have different kind of data which comes from textured meshes or cloud points other than the IFC and BIM models. So of course you also want to use such kind of data for visualization, for example. And here we have seen how we can put all of them together inside the same view. Here we are starting looking to see something more concrete, some more practical workflows in actions, because so far we have only seen viewing, which is amazing on itself, but it's nothing if you cannot update the models. So here is an example in which we can, from the same buildings that we have seen before, go into the BIM platform, on the openBIM platform, update the model. In this case, we will just simply add another building to the federation. And so here is the BIM user that is doing the work. And from the GIS side, everything gets updated immediately. What this means is that the next time that we look at that region, then the model will get the updated information, in this case with another one more building. We will see other examples later on of this in action. Of course, remember that we have both worlds in the same view, so we can combine the IFC world, the openBIM world, with the GIS data. And we can also connect to other external systems as well. So for example, here we are querying the facility management system. What this means is that we are looking at the ticket open for the objects and the assets that are available. So here we have three players that are playing: the GIS world, the BIM, openBIM world, and the facility management system. Each one has its own data. Nothing is replicated, but thanks to the use of APIs, of course, you can query the different system and have the up-to-date information all together in a single view. And of course, all the information available in the facility management system, you can have them displayed. If someone, for some reason, updates the facility management system, then it will get updated in real time. Of course, it is always possible also to navigate the models on the GIS map with the use of virtual reality. This is useful for other use cases, such as, for example, site inspection before going to the actual site, and so on. Moving to another different example, here we are looking at the Naples Central Station. This, again, is the Naples station that has been modeled with 56 different IFC models. So we can see that we can play with the maps that are available, and we have the model geolocalized and placed on the map. So as I said, this is a federation of 56 IFC models. And of course, what you can do is that you can select objects and see the attached information. Again, here we have images and documents. But again, here there is the GIS world, the openBIM world, and external documents. So there are three players that are exchanging information without the need to copy them over. This is another interesting example because data can be streamed live. Then the IoT applications, like the one that we will have a look at, comes actually naturally. We have dashboards to see the actual data coming from the IoT sensors, but we can connect them to the IFC entities, so to the openBIM model. What can be done, for example, is that you can actually color the model based on the values that are actually available in the IoT sensors. So this is, for example, useful to keep track of whatever is needed to show alerts or try to intercept where maintenance is needed, and so on. And you are looking at one single bridge, but you remember that we are on the GIS. So imagine what you can do if you have all the bridges of an area with all of this information to see what happens on a territorial scale. There are other use cases and other kind of models that can take part of the play. This is an example of an IFC road model. It's IFC 4.3, and this has been developed during the projects of buildingSMART International with the development of the new standard for the linear infrastructures. And of course, there are also new kind of IFC files that we are working on and developing. This is quite a new example, is from the IFC tunnel project, which is IFC 4.4 is still in progress, but still the information, the standard is quite stable now, and so we have started to experimenting also with this. Bridges as IFC 4.3 entities and schema is already available and quite stable. Here we can see an example where we can also, again, navigate with the use of virtual reality to do inspection of the bridge directly from the virtual reality. And it is now more and more happening that we see different kind of models, IFC models, that try to model everything. This is a power plant, for example, for an Italian stakeholder. So the IFC models start to model everything, but the data that is contained in it is the same for the structure of the data is the same for the model. And what this means is that after this example that we are looking at, where we can see also another cloud point, this time of a football stadium, what can be done on all the data that is available is that we can start query the data from the GIS side. So here, another example of a railway combined with the cloud point. So now we have both the cloud point and the actual IFC rail model. This is a 50-kilometer railway, and both the model, the 50-kilometer model, and the 50-kilometer cloud point is loaded in real time. So this again is what I was talking about when I was talking about scalability, even for linear, very long linear infrastructures. But then, and this is where the power starts coming in, is that remember that we have GIS data now, but also BIM and in particular openBIM data. So from the GIS side, we can start to do query. And the query that will use data will be the data that is available in the openBIM models. So the spatial analysis that the GIS people will do, it will actually be based on the IFC data. Here we are looking at the data analytics of the IFC spaces based on a radius around a building. And in particular, we are looking, for example, for rooms or compartments based on the different type of uses, such as commercial, offices, and so on. So really, we can start to see how combining these two technology together improves both worlds. And again, I would like to point out how important is the fact that everything happens in real time and nothing is exchanged statically. So what this means is that the BIM users will continue to do what they have always done, that is to update the model. And what happens is that if someone from the BIM side starts, for example, to move objects around, then in the GIS side, everything is updated automatically because everything is exchanged via API and not copied over. So this happens for the geometry as well as for the data, for the actual properties. So we have seen maps, GIS, IFC models, point cloud, spatial analysis, and GIS and openBIM, everything in action in the same environment. So we have seen how we can combine the GIS world with the openBIM world in a dynamic connection between the two platforms, the Esri and the ACCA platform. With that said, I would like to thank you very much for your attention.
Thank you, Michelangelo. So the third finalist in this technology solution category is Tsinghua University.
Thank you for the great opportunity to share the vision of CBIMS with all of you. In the next few minutes, I will talk about the concept and the capability of CBIMS and how it uses the power of openBIM and adapting China national standards and provide a customizable technology solution for BIM checking. Right now, BIM checking is happening all across China, but the current status is very fragmented. Each city has its own format, not IFC. Besides, the terminology used in the model, the modeling requirements, and the building regulations to be checked are all different. Let's look at the image on the left, which is the map of China in the Warring States period, 2,000 years ago. The standards among each state were not unified. The communication between states were hindered. So, what happened after the Warring States period of China? Qing Dynasty unified the entire country and standardized things. For example, characters, currencies, metrics, and wheel tracks were standardized, and the people can communicate much better. Today, we are at the Warring State period of BIM in China. And our solution based on openBIM is the key role to standardizing China's BIM checking. Our project has 4 steps: exporting IFC models from BIM software, model quality checking, building code checking, and creating city information model. First, IFC models are exported from both domestic and international BIM software. Second, we use MVD to do model quality checking. Third, the model will go through the building code checking supported by structured natural language, which is a China national standard proposed by our team. And there is a building dictionary. It is used to unify the terminology between models and the building codes. Finally, the model will enter a CBIMS platform to export city-level application. And this process is based on the CBIMS framework for BIM checking. There are 5 letters in CBIMS, obviously. C means China. B means building dictionary. I means IFC. M means MVD. And S means SNL, structured natural language. We will take our practice in Shenzhen, the 3rd largest and the most open city of China, as an example to explain these 5 letters. Let's talk about the C, China. There are thousands of building codes in China. There are hundreds of cities in China. There are dozens of new emerging BIM software companies in China, and the link is needed. We create a bridge between openBIM technology and China national standards. We create CBIMS as a unified BIM checking framework to link the different cities, software, and building codes. Let's talk about the B, building dictionary. Building dictionary is a tool that maps terminologies of models to building codes. For example, terms from this MVD, wall, fire endurance, and the terms from the structured natural language, cable well, wall, fire endurance are mapped together. In Shenzhen, the building dictionary is composed mainly by 2 China national standards. And we added extended terms in Shenzhen city standard to ensure the building codes could be checked. Let's move to IFC. We all know that IFC comes with a lot of advantages, such as its neutrality, openness, and precision. But in China, people still need help to implement IFC in BIM checking and CBIMS. For example, the loss of information in IFC export, the lack of visualization, and the relatively large file size. So we released a Shenzhen city standard, Shenzhen 114, to specify the way of implementing IFC. At first, about information loss, we proposed a key feature list. It defines the necessary information and the standard export manner in IFC. Secondly, visualization is improved by 5 LOR, level of rendering. Level 0, there are no materials or shading. Level 1, there's basic coloring. And level 2, we defined a standardized name site of FC material. Render is consistent yet limited. And level 3, user textures can be exported to reflect the desired appearance. And level 4, there are UV textures, which can represent more detailed texture effects. And level 5, there is an IFC with a physical-based rendering property sets. The last IFC improvement is the data compression tool for large IFC files. We have collected thousands of models in Shenzhen. The average compressed model is only a quarter of the original size. The next letter is M, model quality checking with MVD. We categorize common MVD rules as 12 templates. User can customize MVD requirements on CBIMS.org.cn by these templates. They can also export MVD into machine-readable format and human-readable format. This video shows the quality checking process. CBIMS.org.cn provides rule compilation and a management tool, including building dictionary and MVD for quality checking. It's a platform developed by us. For example, base coordinates check whether the base point coordinates and elevation meets the requirements of Shenzhen. And the property value check whether the value of the door properties meet the requirements. And the material mapping check whether the material mapping of the components meets the requirements. In Shenzhen, exterior wall needs to be textured. Color, check whether the components meets the color requirements. And relationship, check the connection relationship between components. And let's talk about S. The structure, natural language. It is a machine-readable language for building codes, but also have some human readability. Take this clause from fire prevention code, for example. The fire endurance of the wall around the cable well should not be less than 1 hour. And following our steps, it could be turned into the machine-readable SNL format. We designed 25 sentence structures in SNL. In this case, there are 2 types of sentence structure being used. Then, tons of objects and properties from the building dictionary can be referenced in the sentence, such as a building, cable well, wall, and fire endurance over here. Moreover, 48 common relationships are supported in SNL, like a geometry relationship, orientation relationship, and distance relationships. In this example, the term has and the boundary has are both relationships. Additionally, 17 operators and comparators are defined to enable logical operations like the greater than or equal. By combining them, numerous building code checking rules can be customized. Currently in Shenzhen, 102 construction codes, 166 fire prevention codes, and 56 planning approval codes are translated into SNL rules. There's another video showing the SNL editing and checking process. By using CBIMS.org.cn, either human-readable regulations can be converted to machine-readable SNL rule sets directly. It's the Chinese version. And these rules are applicable in the model checking software developed by us, CBIMS Manager. And for example, orientation relationship has checked that the transformer room on the first floor should have an exterior wall. and the geometry relationship in. Check that the evacuation door of the transformer room on the first floor should be in an exterior wall. And distance orientation relationship, vertical distance or set boundary. Check that there should be an evacuation light sign directly above the safety exit. And distance relationship, path distance. Check that the distance from any position in the classroom to the evacuation door should be less than 27.5 meters. And the semantic relationship has property. Check that the clear width of the safety exit should be no less than 900 millimeters. We found the design of SNL valuable in terms of making building codes computable and customizable, and we hope to share it with others. As a result, there are 4 outcomes. First of all, an extensible framework, CBIMS, is released. Building Dictionary, IFC, MVD, SNL are combined for BIM checking for different Chinese cities. Secondly, this solution pushed the newly emerged Chinese software companies to uniformly export IFC for information in Shenzhen, and we made it. Thirdly, we applied openBIM to a mega city level. Up to now, in terms of new buildings, 6,362 high-quality IFC models from 219 projects in Shenzhen have been delivered utilizing this solution. Additionally, we have been 14,220 high-quality IFC models from 741 existing building projects delivered using this solution as well. This includes many projects without existing CAD drawings, whose IFC models are created from point clouds. Finally, numerous IFC models are collected and imported into a SIM platform to support city-level applications. Facts have been proven that openBIM technology has good feasibility in data storage, in loading, management, and visualization. Currently, we are working to apply this framework to more Chinese cities. Ultimately, we hope that an open permit alliance can be formed in China. Thank you again for your time and attention.
Okay, we'll just start to make our way back to the stage. Thank you. If the other presenters could also join me, I can see starting to make your way up. That's great. Please come on down. Great. Thank you for your presentations. We'll open the floor to the jury. Whoever has the first question, please take it away.
For the first submission with the IDS checker, great software.
Yeah.
How to deal with multiple IFC files if you have like 100 files, or how is that being handled in your software, in your technology?
Oh, okay. So can you repeat your question? Is if you have more than like 100 of IFC files, how to check, right? At the moment we start developing this software, we advise the user to combine the models into one single IFC file, and then we upload to our portal to check. So at the moment we check against each time for one model at the moment. Yeah.
Yeah, thank you.
Yeah.
Can I switch?
Yeah, of course you can.
Yeah. For example, I have one for ACCA. From an output perspective, let's say, are you enriching the IFC files using data from the GIS domain? And I can guess that probably, but I don't know. And if so, which, let's say, object identification strategy are you using to Because you mentioned that you are visualizing, well, we saw it, both domains at the same time, but as an output, how are you handling that?
Yes, well, first of all, regarding how we identify different objects, we can use the UID that is available for the IFC entities. And we think that this is very important because we always think that, as we also have seen in the examples, the IFC models are the geolocalization of information. So once you have this model, possibly on the map, you are able, with the UID, to identify an object. And with that UID, then you are able to connect to other systems, such as the GIS world, or other external systems as well, such as the asset management systems, facility management system, and so on. In practice, actually, we have seen that others have already identifiers for their asset, especially companies that are already doing, and most of them are already doing the facility management. So they have already their own legacy systems where objects are already identified. So many of them prefer to use such identifier to replicate them keep them in the IFC model and use this. With regards of enriching the IFC model with the GIS data, this is certainly possible. As I said in the beginning, we have shown the potential of the technology and some of the use cases that are the most common and that our customers have required to solve first. This means that it is possible also to create other use cases and solve them. But for this particular thing, I would say that yes, it is possible to have GIS data and enrich the IFC model with it, but you have to be very careful on why you do this, because replicating data, that was the point, was not, we think it's not the perfect solution because you can always query the GIS side or the IFC side to have the information up to date. But of course, there are use cases where you need such data, such as snapshot in time with the data, whether it is in the IFC model or in other places, because other software are consuming them to do their things. So if it is part of an openBIM workflow where you then keep the model and keep doing things, then I would agree that this is possible to implement, to do such things. So yeah, it will definitely be a possibility. Thank you.
Hi, I had a little question for the third group. What you mentioned, the SNL, what's the difference between your creation of invention of SNL? What's the difference between this one and the EDS? Why we don't just use EDS? That's about information delivery specification. Have you tested it or just?
Okay, that's a very great question. In terms of IDS, we understand that it has become a BSI standard, and apparently it has become a trend. And we understand that because the idea of IDS is fascinating. It combines sufficient human guidance and a checkable rule set together. So both parties can benefit from it. And in our position, our work with MVD rule set and structural natural language rule set, especially the structural natural language rule set, we created numerous operators, mostly operators, relationships, operators, comparators, and we try to link them with those actions in human world, and utilizing all those operators, we kind of change the checking process to a group of arithmetic computations. So the checking can the complexity of the checking can be turned down, and it is actually checkable for all those hundreds of thousands of building codes. And our focus is on the regulation checking, which means it's not just checking for the existence of the property, but the design. If the design is right, if the design is according to the compulsory building regulations.
Thanks. Just for saying try IDS is powerful than you think, maybe.
And one more question for the last one. So you have a technology now that all the building permit rules are linked to also IFC, so that you know what rule, how it should be checked if you have an IFC file, for example, from a designer. That's now linked to each other, so that your technology knows if a door has certain properties, then it fits with this requirement from the national government.
I'm not sure I understand your question correctly.
So the SNL, that's a new kind of technology that you developed.
Yeah.
But we are also here for the openBIM IFC standard. It's the schema.
Yeah.
And you linked both now to each other, so that if you know if in SNL it's a door, you know how it should be described in IFC, for example.
Yeah, that's the job of our building dictionary. It kind of fulfills the role of a BSDD, but the use case, the problems we are facing is that the very detailed wording in between different building codes. What we do is actually creating the content, the connection between different national and local building codes, and in between different disciplines. They have different terms for the same components. We are creating the very low level content. So we think our building dictionary is actually a addition to the BSDD. It's several levels down. So we think if you are interested and you think our building dictionary is useful, we will be pleased to contribute our content to BSDD.
Yeah, okay, that's cool. So, but in your own dictionary, you have also the IFC schema as a link, or do you already link to BSDD for that part?
We haven't linked to BSDD already, but we do have a tree structure to link all those components directly to IFC.
Okay, thank you. I think we've probably got time to squeeze in one more question to each of the projects here, ACCA and Wings and Associates.
For ACCA, you have like the georeference problem or issue, or between IFC and GIS, because probably GIS maps also have different georeferences. And how do you deal with the combination of georeferences in IFC, different layers in GIS, and those kind of...
The question is very clear, because this is a common problem. It actually has been tackled during the development of the IFC 4.3. And it's been refined on the IFC 4.4, because before that, there was no standard way to express in an IFC model what was the geolocalization information. There have been some try, especially from buildingSMART Australia, if I remember correctly, to do with some custom PSETs, but that information was not enough. So now with the new IFC 4.3 schema, it's possible to have this information standardized and clear. There are still problems, because then on export, applications are not yet supporting fully this kind of information. But I think that we are getting there, because during the working groups, software vendors have been more and more involved and are starting to export this geolocalization properly, which means that we will have that almost completely automatically done. At the moment, if this information is not available in the file, it's possible to do it manually. And the user specify the information for georeferencing, and then when it is passed to the GIS side, it is automatically converted to the reference system that is used on the GIS side. So still an ongoing problem, one of the most common one, but it's going better with the standardization of how to exchange this information.
Thank you.
And is there a final question for Wings and Associates in the middle here?
Maybe you have mentioned it's for the, I think it was the first one, the openBIM checker. And sorry if you mentioned, because which IFC versions of the schema are you covering within your solution? I mean, for example, IFC 4.3, it's in the roadmap as well, or because maybe you mentioned in
yeah. Sorry. Yeah.
A bit of water.
Excuse me. Yeah. If you don't mind my voice, sorry.
Yeah. Please.
Yes, it's in the roadmap.
Yeah.
And now we support to 4.0. And because we have quite a lot of infrastructure project, so we are roadmap is the next step is supporting 4.3.
Okay.
And then it will going on. We are committing on the development. Yeah.
Okay. Thank you.
And because our software is for everyone, so yeah, because we have a lot of passion to put it into everyone to use. Yeah. Sorry
Thank you.
about that.
Okay, I think we will wrap things up there. Thank you for your questions. Thank you to the three groups of presenters here. I'll now break away with the jury. We'll make our decisions, and we will see you at the dinner tonight. Thank you very much.
Thank you.